for the past 30 days, humanity has created more digital images than the entire human civilization have created before 30 days ago. So think about your Snapchat pictures that harnessing visual data, enabling computers to be able to perform intelligent visual tasks is one of the most important goals of the field of artificial intelligence. Within each subfields, we have slightly more focused goals, but they all contribute to the global quest of intelligent machines. Some of the subfields you hear about are machine learning, focusing on statistical modeling of data, computer vision, focusing on, this is the rest of today's talk, enabling machines to do visual understanding. Natural language processing is to build machines and algorithms that can read and communicate like humans. Speech recognition is to build algorithms and machines that can understand speech and turn it into text. Robotics is also as old as AI, which is focusing on building physical machines that can move and manipulate and navigate. But all these fields today are interconnected and have become part of the larger field of AI. And within machine learning, you hear a lot about deep learning. That is a recent development of the research from machine learning that focuses on neural network research. The first step towards teaching a computer to see is really enabling the ability of object recognition. Imagine this is the teaching process to the machines. We want to show computers some examples of a object, say cat, and then the machine, we design a mathematical model that can learn from these training images during the teaching phase. And eventually, the computers will learn, and then when you show it a new picture of cat, it'll say, oh, this is cat. That's what we call object recognition in computer vision. Convolutional neural network are high-capacity models with a lot of parameters. You can think of it as a brain-inspired model. I want to make sure that you don't walk away thinking this is a replication of brain. There is a lot of confusion in the world out there that's saying deep learning is just a brain. It is not. The neuroscience and have told us some of the mechanisms of neural network is different in the brain, but this is a brain-inspired model. Why? Because the basic building block of a convolutional neural network is a neuron-like unit. It takes inputs from other units and sends outputs to the next unit. So that is a neuron-like unit. Also, similar to brain, it's layered in hierarchies. This is a high-capacity model. It's huge. This is a small model we use for object recognition. And the typical model like this have 24 million nodes, 140 million parameters that the machine has to learn, and 15 billion connections. And this is already nothing. This is an outdated model. The models today are even bigger than that.
All data is the heart of AI, right? If you think about what it is fundamentally, it's about these deep neural networks that are reasoning over large amounts of data. So in technology terms, garbage in, garbage out. If you don't have high quality data to begin with, then the reasoning and decisions that are made on that are going to be completely wrong. So some of the interesting things about that are you need to create large pools of data and put them into data lakes in order to be able to really achieve the impact you need from deep neural networks and machine learning. And the other thing that's important is you can't over-curate your data. So I know you talked about mainframes and legacy kind of being a key part of that, Matt. If you think about the fact that they have very constrained data sets, you've lost a lot of the detail in the data when it passed through mainframes. Sometimes those raw signals are the real intelligence and insight that you're looking for. So the more you can get raw data and bring it into a data lake and reason over it, the more successful you'll be.
Oh man, it's Stanton Hicks. Do I know it?
So I have to say it is pretty incredible. By around 2015, our lab, among a couple of other labs in the world, like Google, Microsoft, UCLA, Berkeley, we developed the first machines ever that can speak human-like sentences when seeing a picture for the first time. Then we have taken this technology a bit further. Now we have developed algorithms that can actually speak multiple sentences, looking at different parts of a scene, because our visual world is complex. And we see different stories in a scene, and we're able to train algorithms to see the same level of complexity, and they can even put them together into paragraphs. Granted, they're still not perfect. There are mistakes. For example, in this picture, the computer sees two buses driving instead of a double-decker bus. But the progress is enormous, and we are working really hard, both at Google as well as Stanford, to drive these algorithms further. In self-driving cars, we have depth sensors and LiDAR sensors. In hospitals, it's also important to have depth sensors instead of camera-like sensors. But we need to recognize human activity. So in this particular work we just published, my students developed an algorithm to understand human gesturing using depth sensors that goes beyond the RGB domain. And in a very similar setup, we collaborated with the European train station in Switzerland that put hundreds of depth sensors in a station and help the station to monitor 70 million passengers every year and track their behavior throughout this train station. You're looking at a top-down view of every moving dot is a passenger or customer to the train station or traveler, and tracking their movements.
Lighthouse is the first home security camera that combines a regular internet-based camera with the power of AI, and the result is a smart camera that could be the best yet. Founded by a team of ex-autonomous vehicle gurus and the first incubator at Andy Rubin's Playground Incubator in Silicon Valley, Lighthouse allows you to make natural language requests of its AI rather than trawl through hours of footage. For example, you can ask who was jumping around the living room between certain times, what time did your kids get home, and whether your dog walker came today. Thanks to a custom 3D sensor and its own AI, Lighthouse can also distinguish between animals, children, and adults, and the halo outlines provide an easy way to see at a glance who is who. In our demo, it recognised the difference between the male father and the female dog walker. For the times where there aren't unknown strangers, you get an alert straight to your phone, and you can then watch the scene live in full HD. From there, you can sound a siren, speak through the camera, such as welcoming someone to your home or warning them that they're on camera, or call the police, all straight from the app.
Yeah, so a couple things they're trying to do with the Nest Cam IQ is something called familiar face alerts. So it's trying to read people who are in your home so you can get alerts about who's there. The other thing that it tries to do is zoom in on action around people. Yeah, so Nest Cam IQ is their latest model. It represents what you expect from traditional security cameras today. So you have a 2D color sensor, night vision, two-way talk. And with Lighthouse, as you would expect, you also have a 2D camera, two-way talk, night vision. But we also have a built-in siren. So if you see something amiss, you can sound a 100 decibel siren. But what really separates Lighthouse from any other camera before it is the 3D time of flight sensor that you see right here.
To give you a better idea about how the 3D sensor works, it actually measures the amount of time it takes for light to hit an object and bounce back. So it understands the distance and therefore understands the 3D structure of the environment and everything in it. So with that, you get a ton of additional data, like the shape of an object, how the object is moving, as I said before, the distance. And that data is fed into our AI models that we've been training for years to accurately predict what's going on in your home.
If you think about agriculture, education, healthcare, government, manufacturing, oil and gas, every single industry is being transformed by computing, by AI. And government can use a lot of computer vision technology. We are seeing satellites, private satellite companies sending out satellites to collect a lot of images.
If you think about it, technology is really there to take out the noise. It's really there to kind of simplify and streamline what we're doing. It doesn't absolve us from investing in our own humanity. Good thought and good judgment is a collaborative process, and AI is quite far from that, and that's what makes us unique. So if we're going to be automating things with processes that can run 24/7 and munge much more data than we could, then the owners of that technology, which are the humans, need to be able to put a lot of good thought into what you're implementing it for, and then have the controls in place to be able to understand where to apply it and where to not.